We'll proceed in summation to integral calculus in for two dimensions. Okay, very difficult discussion we have started. Summation to integral calculus in a way that how I can divide my problem, how I can divide my problem into n different parts, dividing the problem into n different parts and solving it part by part, and then sum it. Divide a problem. If someone has problem, then divide the problem into n different parts. Solve part by part and then sum it. If summation is not very perfect, then make n tends to infinity. Okay, where it is and how it is, we have many times we have discussed about it. So what is new? We are taking care one. We are taking care of the vector only. Whatever calculation we are making, in that calculation we are taking examples only through the vector, only through the vector, because vector is the most complete thing in mathematics. Why vector is the most complete thing in mathematics is vector is the only entity which talks about the vector is the only entity which talks about the direction. Otherwise, everything talks about the everything talks about everything. I mean, without the direction. Everything talks about everything without the direction. In that sense, vector comes to rescue where magnitude and direction both are there. And with both, we can estimate our. So, concept is saying that you break problem into n different parts. Each part solve the problem, then add part by part. Okay, we gave example of calculating the circumference. For calculating the circumference and to introduce the vector, to calculate the circumference and to introduce the vector. Okay, to calculate the circumference and to introduce the vector. That is one concept. If this is x-axis and this is y-axis, this is x-axis and this is y-axis. Now idea is to calculate the circumference. Idea is to calculate the circumference of a circle. It is a curve equation. Circle is not anything extra. It's a pure curve line. It's not a straight line. It's a curve line. If it is a curve line, there is an equation in terms of y and x. Y equal to a square root of a square minus x square. Y equal to plus minus square root of a square minus x square. If someone compute in this fashion for different x, if someone compute different y, then it will make a line and that will look like a circle, that will look like a closed line, and it will look like a circle. Y equal to x square. It will, if I extend x from minus to plus, it will look like a parabola. Okay, I believe it would be different for the conical we will see. There is something called paraboloid and so many things in three dimensions. Anyway, now concept is that how we can calculate the, now concept is that we cut the x-axis into n different parts. We cut x-axis into n different parts, and then we take one particular part, say ith part. If ith part goes up, it hit the parameter here. This is the length of the parameter of the ith part. If I cut x-axis into n part, minus a to plus a, n part, each part has a width of 2a by n. If I cut x-axis into n part, where each part is 2a by n, if I take any ith part, any part, if I go up, it hits the circumference. This is the ith section circumference. If I represent this as pi, that is parameter ith section parameter, then total circumference that will go from here to here, because I have taken x here from here to here. Okay, then top circumference, I would say top circumference of the circle will be summation I equal to 1 to n perimeter of the ith section. What is parameter of the ith section? If I take parameter of the ith section, then this point goes up and it hits here. These are the 2 points on the parameter of the ith section. If I connect this point and origin, this is P1, P1 vector, position vector 1. This is position vector 2. If I say P2 minus P1 or P2 minus P2, I don't know which one it will be. I believe it will be P1 minus P2. I think so. P1 minus P2 will be a new vector that will connect these 2 points, and it will be like this. This is P1 minus P2 vector. This is P1 vector. This is P2 vector. P1 vector connects this point and this point. These 2 points arises because if I take this intersection on x-axis, this will come as delta xi, ith section delta x. If it goes up, then it will come like this. Point P1, point P2. P1 vector, P2 vector. If I am trying to get this length, then I'll connect point P1 and P2 and I'll make like this. Length of this vector, that is delta P or P1 minus P2, is the length of curvature. Okay, someone would say it is not the same. This is a straight line and this is a curved line. Then we make n tends to infinity. If n tends to infinity, this curvature length means if I cut into n part and n tends to infinity, this delta xi, ith section delta x will be extremely small. In that fashion, it will go hit and this parameter length will be extremely small. In that fashion, length touching two end of the parameter and parameter would be same. This is what the assumption I personally don't like, but this is how it is. This is what assumption I personally don't like, but this is how it is. Okay, then I can say summation I equal to 1 to n tends to infinity delta p of the ith section, magnitude of delta p, that is a vector connecting p1 and p2 point, or p1 vector minus p2 vector. Whatever the vector is resulting delta p vector, its magnitude of the ith section. So this is the, if I do, then I'll get the circumference. This is one scenario. Now, can I use this fundamental? We will go with other things. Can I use this fundamental to calculate the area of the circle? How can I use this fundamental of calculating the we have now delta p. Okay, how I can use this fundamental of calculating the area of the circle? Now I have to find area of the circle. Now to get the area of the circle in similar fashion, now I have y-axis. Area means two sides. Area means two sides. Length means one side. Volume means three sides. Okay. So weight means four sides. Weight, four sides. Volume into density is the weight. It has four sides. One side is the density side and that is invisible. Otherwise, it has four sides. Sides. So if I'm talking about calculating the area with the vector, not any other way, with the vector. Okay. If I had proceeded in calculating, I believe I'll always stop here. What is the length of this delta p? If I say length of delta p, how much it is? This is delta xi. And then if I go like this, then this is delta yi. If this is ith section, for which this is delta x, for that section if I go and map on the y side delta yi, it looks like it is nothing but delta x whole square plus delta y whole square root. That is the length of delta pi. Okay, someone would say, will you get the complete length if you say summation I equal to 1 to n tends to infinity delta pi magnitude, that is square root of delta xi whole square plus delta y whole square. Is it possible? Someone can try. Someone can take out delta xi from here. If someone takes out delta xi, it will become delta xi into square root of 1 plus delta y by delta x, delta yi by delta xi whole square. I can shift it again. It is a square root of 1 plus delta yi by delta xi whole square. Outside the square root, we have delta xi. summation I equal to 1 to n tends to infinity. This is can be said delta y by delta x where delta x tends to 0. It is as good as dy by dx. Dy by dx is a function over x. 1 plus dy by dx whole square is a function over x. Square root of 1 plus dy by dx whole square is a function over x, all complete, into delta xi. This is a pure a sub area, sub area. If I have a function called fx, and if I say fx dx, then it is nothing but underneath fx, what is the area? That is fx dx. Integral calculus is nothing but calculating the area. If this is x-axis, if this is x-axis and this is fx, which is a circle. If I say fx dx, then it will give the area underneath it. But we are trying to calculate, if someone remember, the perimeter, not the area. Now someone will say, where you land up? This is the square root of 1 plus dy by dx whole square into delta xi. Okay, I understand that this can be said as function over x. 1 plus dy by dx whole square root can be demonstrated as function over x, true, into delta xi. What you are saying? I am saying if this is delta xi, then at this point this is function over x. Height into delta x will give the area of a small rectangle. Height by width. This rectangle will not be the top will be again flat and bottom is anyway flat. Okay, but we want curve on top. Just wait. This is the rectangle of this. If I take ith section little forward, then this is the height and this is delta x. Means if I keep adding height into delta x for all the section, then more or less we are calculating area of this, and area of this is nothing but fx dx. Means summation of fx delta xi equal to 1 to n tends to infinity is area of all the subsections inside it, where one subsection width is delta x. That delta x is nothing but 2a by n, where n tends to infinity. Means whatever we are talking now, it is nothing but fx dx integration from minus a to a. What are you saying? You are saying that the square root of 1 plus dy by dx whole square dx integration minus a to a will give the circumference, certain. This is vector technology. What is next vector technology? Can we use this fundamental to calculate the area of the circle? There are innumerous ways in vector itself. We can calculate the area of the circle in this fashion. Okay, there can be innumerous ways. If I see, okay, there are other way also to calculate the circumference. If you taken this is x-axis. You divided x-axis into n number of parts. Okay, another way I believe we have talked before. This is considered this is origin and this is theta. Theta is varying like this. Okay, if theta is varying like this, then I divide this theta. I divide this theta into n part. I divide this theta into n part. If I divide this theta into n part, I'll take any delta theta. This angle starts from here. I take any delta theta. If this is delta theta, then again it hits 2 points. Makes sense? If this is origin and this is the radius that is moving like this, and at one point, okay, it is making theta angle with the x-axis, and then it is moving delta theta. What I am saying is this theta angle that is 2 pi, that is 360 degrees, 2 pi. Theta is 2 pi. In this 2 pi angle, can I cut into n part, divide into n part? Now, if I divide into n part, then I have this angle as first part, second part, third part, fourth part, fifth part, like this. Consider from here to here is the ith part. Okay, this is what I am saying. This is the ith part. This is delta theta I. We talked about delta xi. This is delta theta I. If this is delta theta I, then there are two vectors. One is delta theta I. Now this is the one point. This is the another point. Okay, this is P1 and this is P2. P2 minus P1 will again it will give the length. Okay, summation of I equal to 1 to n tends to infinity delta P ith section will give it. What is the delta P? That is the question. What is delta P? Okay, someone has to find out what is the delta P. Okay, I also don't know what is delta P. If I can try, okay, if this is the point. Now consider that we talk what is delta P? What is delta P in terms of Cartesian coordinate? We saw if this is the straight line, then this is x section and this is y section. Then x square, y square, square root gave me delta P. Okay, if I talk in the polar coordinate system, then what is this P? This is P1, this is P2. If I divide, subtract, then this is delta P. Okay, summation I equal to 1 to n, summation I equal to 1 to n, where n tends to infinity, delta P of the ith section magnitude, it will give the full circumference. Okay, where the this delta theta I tends to 0 means n tends to infinity means this is the first section. This is the full angle 360 degree. This theta I am cutting now. Okay, first section, second section, first section, second section, ith section, like that. We have n section where n tends to infinity. If n tends to infinity, then this is delta theta I. If this is delta theta I, then this vector it is correspond to 2 points on the circumference. This is point P1, this is point P2. P1 minus P2 will give this vector. P1 minus P2 will give this vector. What will be this vector? What is P1? What is P2? Okay, now I'll go ahead. What is that? It is summation I equal to 1 to n delta P. Delta P of the ith section, its magnitude, same thing what we did earlier. It will give the circumference length. What is this point? This point is xi plus yj. If I talk in terms of Cartesian coordinate, this point is xi plus yj. Means if I draw a vector, this point is x1i plus y1j. This point is x2i minus y2j. If I draw a vector like this, that will be x2 minus x1i plus y2 minus y1j. That is nothing but delta xi plus delta yj. That is nothing but delta xi whole square plus delta yi whole square root. That is the length. What about this point in polar coordinate system? Okay, this point in polar coordinate system, if I take this as a circle, what is this point in polar coordinate system? Many times we have talked about it. This point in polar coordinate system, if I take, polar coordinate system, if I take, then this is r, this is radius. Polar coordinate system, two components are radius and theta. This is r. If this is r, then this is theta. So I can say this is r comma theta. But theta is angle and r is length. Both should be in same unit. If I say to coordinate for theta, then this point will be r into theta. If this is theta, then this point will be r into theta. Now this point is r comma r into theta. Then I have 2 points here. One is r comma r theta and another is r comma r theta plus delta theta. Okay, these are the 2 points. If I take a vector, here r minus r gone. Okay, r theta, I have never tried. First time I am trying actually, because first time we are pushing into the a vector concept. First time I am trying. Okay, now it will become r del theta plus delta theta minus r theta. It will become r delta theta. Okay, r delta theta, theta unit vector. If I say I have 2 points, one is r comma r theta. One is r comma r theta plus delta theta. This vector is r unit vector plus r theta theta unit vector. In another, r theta r is constant. Okay, because if we talk about the theta vector, then theta vector is the tangential vector, whereas r vector is this vector. They are perpendicular to each other. This is theta vector. If this angle is theta is moving like this, then I am saying r theta correspond to the theta, then r theta vector is like this. This is the polar coordinate system. There is no much engineering out here. And perpendicular to this is the, because both component in any coordinate system must be perpendicular to each other, then this is r vector and r theta vector are perpendicular to each other. Now I have 2 points here. I have 2 points here. One point is R and another point. I'm sorry. Now this is the x-axis and theta is moving like this up to 2 pi. I have cut this theta into n different parts. Now I am taking the ith part. This is the first part of the theta. Second part, third part. This is ith part. This theta width is delta theta I. Delta theta I. This is the circumference of the circle. This is point P1. This is point P2. If I want to calculate the length of the circumference, then I will take the part by part. For this ith part, what is the length? That is P1 minus P2. P1 minus P2. What is P1 minus P2? What is P1? This point is R, comma, R theta. This point is r comma r theta plus delta theta, or theta plus delta theta I rather. Okay, if that is the case, then this vector will be named as r unit vector plus r theta unit vector, and this vector will be named as r unit vector plus r in bracket theta plus delta theta I bracket close theta unit vector. Now what is the length of this vector, that is delta p, p1 minus p2 delta p. Now full circumference is the addition of this for the all n, summation I equal to 1 to n, where n tends to infinity. Delta p of the ith section is magnitude. Okay, I believe it is all right. I believe it is all right. Okay, if that is the case, then what it will be? Okay, this is the, what is the width, what is the length of delta p of the ith section? What is delta p? That is r unit vector plus r theta unit vector minus another vector p2 vector r unit vector r unit vector plus r in bracket full p2 in bracket r unit vector plus r theta unit vector, one bracket, minus another vector, that is r unit vector plus r in bracket theta plus delta theta I theta unit vector. If I subtract, then first r component will go away. If I am talking about a circle where radius is constant, mind it, radius is constant, radius is not variable. Okay, in that fashion, if radius is variable, then r, it will become r1. If radius is variable, means when we move along the theta, radius will also change. If I'm moving the theta, then radius is moving like this, and it forms a circle. It is true, but there can be scenario where radius also changes with the theta. If at any theta radius is r1, then if I move delta theta I, radius will shrink, because radius is changing with the theta. That also situation we will see, but right now take radius constant, then radius part will go away. Now we have now r into theta plus delta theta I theta unit vector minus r theta. It will come as r delta theta I theta unit vector. Now we can replace our summation, what we are doing now. Summation I equal to 1 to n tends to infinity, and then delta p of the ith section, its magnitude. Delta p of the ith section is r, where r is constant, r delta theta I. This is the delta theta I theta unit vector. This is delta p. Okay, if I calculate the magnitude of this, this will come as only theta unit vector will go away because this is the only component. If there are two components, then I have to do a square and a square root. If there are two components, then I have to do a square and a square root or something like that. Okay, now there is only one component, then I can proceed. Okay, so it will be r delta theta I, r into delta theta I, summation I equal to 1 to n tends to infinity, r delta theta I. R I can take outside. Okay, or if I keep r when it is constant. Now I have come to a same situation. We have delta theta I multiplied by r. Consider r is a function over theta which is a constant. Makes sense? Like I have x-axis and there is a function over x-axis is y, but it is a constant. If I take a rectangle, then in this rectangle I have a y equal to 3, always 3. This is x-axis, but I can say y is fx, but fx equal to 3, that is constant. Or if it is not in variation of x, or someone is very mischievous, he can write fx equal to 3 into x to the power 0. It is variable with the x whatsoever. Now, this is just the humorous. So, it is now we have summation I equal to 1 to n. R, consider R as a function over theta, and that is a constant. And then delta theta I, the way we have demonstrated earlier, it comes to same situation. If this is a theta axis and this is function over theta axis, then we have function that is f theta into delta theta I. This is one sub area. Okay, if I write f theta d theta, then there is a function like this. There is a function. there is a there is a there is a function like this. F theta. F theta d theta will give area underneath it. If I say f theta into delta theta I, this is the area of one subsection. If I add for all I when they are non-overlapping, then it will give the full area underneath this curve, that is f theta d theta. Means we are on the right track. Now we can safely convert summation I equal to 1 to n function over theta into delta theta I as f theta d theta. Theta is 0 to 2 pi. Okay, now this is first we brought the one section, delta p. Delta p is a straight line, but if we make n tends to infinity, it will be similar. Okay, if I am saying this is delta p, which is not the curvature, then if I make n tends to infinity, then it will be so curvature will be so small that it will be equal to the vector length. So it should be perfect. F theta d theta, and then integration sign theta is 0 to 2 pi. F theta is r, which is constant now. R I can take outside d theta, 0 to 2 pi. 2 pi r is the full circumference. I believe it is all right. This is the vector technology. What about if r is variable with the theta? Someone can calculate. No one is stopping anyone. If r is variable against theta, then we have now one is ri plus r theta, r unit vector plus r r unit vector plus r theta unit vector. Another point is one is r1. If theta length is varying with the theta, consider as the theta ith section we are talking, where radius is not constant, radius is variable. This is angle theta I, and that's person if this is r1, this is r2, then r1 minus r2 is delta ri. There are both are varying. Okay, both are varying. In that way, what will be the circumference or something like that? I believe it will be very complex. Someone can try. This point will be r1 r unit vector. This point is r1 comma r1 comma r1 theta. I believe so. R1 comma r1 theta. Okay, and this point will be R2 R in R2 comma. If this is R1, then R1 up, R1 theta plus delta theta, that will give this length. It will be complex. We will see if it is really possible in calculation. Otherwise, we will use this concept in the area calculation also. Take it as an assignment. Okay, if radius is variable with the angle theta, going with the vector technology, how we can calculate the circumference of the ith section? What is the function? Consider r equal to cos theta. And it also, for many times we have described, if you take r equal to cos theta, it also makes a circle where theta goes from 0 to pi, not 2 pi. If someone makes a circle with r equal to cos theta, if this is origin, r equal to cos theta, theta is 0, then r is 1. When theta is 90 degree, then is 0. It goes like this. When theta goes beyond 90 degree, then r is negative. Means theta is going beyond 90 degree, then radius is this, but it is negative. Radius is positive in opposite direction. So if you grow in angle, radius will grow like this, and if finally from 0, it will come to full here. So with a 2 pi, it forms a circle. Then how I can find the circumference with a vector technology that we have described now? Someone can take it as an assignment and he can proceed. Okay, one point is R1 comma R1 theta. Another point is R2. Another point is R2 comma R1 theta plus delta theta. I think so in this fashion. Then it will, if I subtract, it will come as delta R plus R delta theta, something like that. Delta R plus R delta theta, something like that. So someone can try it, and then if see, it will, that circumference will be exactly what we think now. Please do not mind supporting us. +91 is the India country code. 9483160610 is telephone number. +91 is the India country code. 9483160610 is a telephone number. This vector way, especially the vector way, I don't think it is available in any of the books. This is really tedious. Okay, please do support us.